Then you're weird.
You should hear him in the middle of your class.
That's really weird.
It's bad.
All right, let's see who's not here. Okay, everybody's here. Okay, so today we're starting a brand new unit. Hey, y'all just tell me when y'all want to stop talking, and then I'll re-begin. Still working on it? Oh, okay. 2 more seconds. 1, 2. Did you get it? So we're starting a new section today, a new unit. It's the fastest unit we'll ever do in Algebra 2.
I don't know, that last one goes pretty fast.
No, this one's way faster. It's like a week and a half at max.
Like this.
I'll miss the whole unit.
Pretty much. So, yeah. And for you guys who are going on that trip, I've got your notes printed out. Did you figure out which questions?
How did you got this stuff? I feel like a real person to yourself.
Well, that's for example, in this problem, this is my logarithmic expression. So to solve this, yeah, no, not 10. That's LOGs. That's LOGs. The base of LOGs. So I would write the third time. This is exact opposite. Since it's base E, right? And the other base of equal 8. And then you would just use that much. Yeah. Okay. Okay, everybody get one of those? Alright, so today, like I said, alright, now it's time. Sorry, if you weren't done, you can finish it later. But it's time. Today we're starting a unit that will take us about a week and a couple of days. For you guys who are not going to be here, who all's DECA people? So 1, 2, 3, 4 of y'all are not going to be here next week? Or this week, starting today? Okay. Yeah, I don't have that. So unfortunately, you'll have to catch up on all that stuff. I don't have that far in advance.
This is what we'll have to catch up on?
So,
Is this my homework?
listen,
Oh my God.
you're going on a trip, right? They're excused days. I only give you those in case you want to try to get ahead or stay caught up. Then when you come back, you can worry about it. All right. Now, here's the thing: we might not even get through all the stuff that I gave you. So some of that might actually work for the next week. Like for example, we're gonna divide today's lesson into 2, just so I don't have to rush it. That way you understand the difference between recursive and explicit. So that's where we're gonna actually cut today off. So again, we can pretty much get finished with this entire unit in about 7 days. So for you guys who are missing, you've got the papers with you. If you choose to stay caught up, you can. If you choose not to, you'll just have to catch up when you get back. All right, and that's your prerogative. I'm not going to push you in one direction or the other. I will say this though: the videos and exactly what we accomplished that day will be on Google Classroom. Okay, so if you want to see exactly what our days consisted of and exactly how far we made it, you will be able to. Okay, so you can do as little or as much as you want to be caught up by the time you come back. All right?
I wish they put Wi-Fi on planes.
They do.
They do?
But like you can do like the Southwest app. Are you going on Southwest? You can download the Southwest app and then you can do certain things on that.
So I can work on my stuff
No.
on the way. Well, no, but like Rollo stuff I can work on.
No. Okay. You're not gonna want to, anyways. Come on.
Yeah, hey.
All right. So here we go. Today we're gonna talk, guys. Today we're gonna talk about sequences. Today we're gonna divide those into a couple of different thoughts. We're gonna talk about finite versus infinite, and then we're gonna begin talking about this idea of recursive, and that's gonna be compared to what we'll go to next, which will be tomorrow, called explicit. Now, very different concepts, and they also are very, very much related. So the difficulty people have in this unit is just keeping those little fine details where these things are different clear in your mind. That's the trouble that sometimes people run into. So you need to pay attention. Okay, if you pay attention, you won't get lost. All right, y'all know what a sequence is?
Like a pattern.
Yeah, if we're going to define it, we would say it's a set of numbers and exactly what you said, Katie, with a particular order or pattern. And y'all know what patterns are, right? There's a very consistent change that's happening to get from one number to the next, right? That's what a pattern is. It might be something as simple as adding 2. It might be something as difficult as dividing by 3 and adding 12. Okay, it could be difficult patterns. But a pattern it's a systematic way that the numbers are changing, right? So when we talk about a sequence, we're going to talk about a group of numbers that you derive because you follow certain pattern. Now, when we talk specifically about each number in that pattern is called a term. Each number in that pattern, in that sequence, would be referred to as a term. So it's like every number in that pattern has 2 numbers. It's like first term is this, second term is this, and we'll talk about that in just a second. All right, now when it comes to sequences, you got 2 types. All right, and I'm not talking about the formulas and the way the numbers are changing. I'm talking about the types of sequences. You have finite and you have infinite. Y'all know what the word finite means?
Small.
Not.
Yeah. So
Like,
what's infinite?
Not
mean?
not infinite.
A lot of times it's easier to define the infinite, right? Infinite means what? Doesn't stop, keeps going, right? So a finite means it does what?
No beginning and end.
It does stop. Okay? So if I'm talking about a finite sequence, I'm talking about a sequence. Would y'all please stop talking back there? A finite sequence is a sequence with a limited number of terms. It's a sequence with a limited number of terms. And if I was representing all of it at once, here's what it would look like. We'd have our brackets, and then we'd have something like this. 2, 4, 6, 8, and then the brackets close. Okay? How many terms are in that sequence?
4.
4, that's it. That's a finite sequence. Now, I know that you see the pattern. It's very simple. I'm not asking you to do that right now. I just want you to understand that a finite sequence ends. Okay? But an infinite sequence does not. So an infinite sequence is a sequence with unlimited terms. And if I were representing it would go something like this. 0, 1, 2, 3, dot, dot, dot. What is dot, dot, dot telling you?
It continues.
It's just going to keep on going. That's the difference between how we will represent a finite sequence versus a infinite sequence. Now, there's one little trick to this. You might even see a finite sequence do this kind of thing, bless you, where it goes like 2, 4, and then they go dot, 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 and then do like 18. So you might see dot, dot, dot on a finite sequence, but what does it close it out as? A number. So basically this one is just saying, hey, it's going up by 2, and it goes up by 2 all the way until it gets to number what? 18 is my last number in the sequence. So you could see a finite sequence use dot, dot, dot. It would be like that. Y'all understand the difference? Infinite sequence, though, your brackets will end on the dots. Okay? And that's just saying to you, hey, this thing is going to keep on going. All right. Now, term notation. You need to understand that when we talk about the first term in a sequence, it will always be named A sub 1. A sub 1. It'll say A sub 1 equals this number. Okay? Or it'll give you some stuff and it'll ask you to find A sub 1. A sub 1 means your first term in that sequence equals this value. Okay? A sub 1, the first term. Every subsequent term after that is denoted by A sub n, where n is the term number in the sequence. Hang on just a second. My dad is here and needs a calculator.
Y'all can just go for me if I
It's bad. No more class.
No, you did not, Dave. No, you did
I
not.
actually have a key right here, so I can.
I thought so.
I just forgot. Y'all think about locking me
Hey, I
out?
do that all the time.
We all like, maybe we shouldn't let them in.
I don't know, you're on video.
That would have been funny.
Oh, good idea. Okay, so for example, is this a finite or an infinite sequence we have here? Definitely, right? Now, I can say to you, A sub 1 equals what? And you know the answer. What is it? 1, right? Because you see the first term. It's 1. I also could say A sub 4 to you, and you know it as well, right? 13. How did you locate the fourth term? Right? So you went 1, 2, 3, fourth term's 13. Now, to find the A sub 9 and A sub 12, what do we have to figure out? We got to figure out the pattern. This is a pretty easy one, right?
Yeah.
What's happening every time?
Adding 4.
It's adding 4. And what term did they give us last?
17.
And that is which term? The fifth term. All right, so what's the sixth term? 21. Seventh term. Eighth term. Ninth term. I'm going to pause right there because wasn't that one we needed to find? All right, now let's get back to it. What's the 10th term? 11th. 12th. And there's no reason to go any further because that's the last one that they ask us to identify. Easy stuff, right? A sub 1, first term. Any other term from that, they're going to say A sub blank. And that blank represents the term that they're asking about. Okay? So y'all good so far, right? Now, like I said a second ago, when it comes to sequences, every term, basically, there's two values. So you could actually write sequences as ordered pairs. And you sometimes will see that in a table format. Now, you guys are familiar with tables, right? That top number, we usually call it what? In the past. The top number, the top row, we usually call it X, right? And the bottom number we refer to as Y. So X, the top number, that's our domain, if you will. The domain in a sequence is a set of all of your term numbers. Let me explain. It means that's the first term, second term, third term, fourth term, fifth term, right? So your X values represent your term numbers. The Y value, actually, that second row, will refer to the term values. So it's like I'm saying this. What is my first term's value? 1. What is my second term's value? 5. What's my third term's value? 9. You get it? That is the idea of a sequence being represented by two values. The first value, of course, is your term number, and the second term, or the second value, is your term value. Now, the domain, that's the X. It will always be, in that infinite set, a set of all natural numbers. Y'all remember a long time ago when y'all were defining what the different types of numbers there were, like whole numbers, rational numbers, irrational numbers, natural numbers? Do y'all remember these?
No.
Do y'all remember what we called natural numbers? Anybody?
No.
We called them counting numbers. We called them counting numbers. Natural numbers are counting numbers. So here's how you know. That's the way you should remember where natural numbers start. When I go to count something, if I'm trying to count how many students are in here, do I start over here on this corner and be like, that's negative 13 when I'm counting? Where do I start? I don't start at 0 either, do I? I start at 1, and then I go to 2, 3. You don't go 1, 2, 3, 3.7. You count all the whole numbers starting at 1. 1, 2, 3, 4, like that. Okay? So when we talk about our domain, we're talking about our term numbers. Your term numbers have to start at 1, which I will refer to a little bit more tomorrow when we go to explicit rules, okay? But today, we're dealing with what we call recursive formulas, recursive rules. Okay? Recursive formulas do this. It is a rule in which one, or sometimes more than one, previous terms are used to generate the next term. You see, in recursive formulas versus explicit, which we're talking about tomorrow, your mindset has to be a little different. Recursive, I like to think of it as it's building. It's building off the previous term's value. Where explicit, each term is kind of defined by itself. Okay? So recursive, I want you to remember that it's building off the previous term. Are you with me? What's recursive do? It builds off the previous terms. Explicit, what we do tomorrow, that the values basically, they're independent. You can define one without the need for the previous one. For example, in recursive formulas, if I want to find the 15th term, you know what I need? If I want to find the 15th term in a recursive formula, you know what I need? I need the 14th term. Okay? If I want to find the 90th term, guess what I need? I need the 89th term. Recursive needs the previous term to find this new term. But in explicit, what we're doing tomorrow, if I need the 100th term, I can find the 100th term immediately. I don't need the 99th term. If I want the 87th term, I can find the 87th term. I don't need the 86th term. It stands alone. Recursive calls on the previous term, where explicit stands alone. So we're obviously going to deal more with explicit. But we're on the recursive, so that's what we're doing today. Okay, you with me? One of the most popular recursive formulas is the Fibonacci sequence. Y'all ever heard of it? It goes like this. It goes 0. See if y'all recognize, or how quickly you guys, y'all are all honor students, see how quickly you recognize the pattern. It goes 0, 1, 1, 2, 3, 5, 8, 13, 21, ... How quickly did y'all find the pattern? Immediately? Would you like to explain it?
You always add the two previous numbers and that's how you get it.
That's exactly right. You take the two previous numbers and you add them, and that gives you the next term. So look, what's 0 plus 1? 1. What is 1 plus 1? 2. What is 1 plus 2? 3. What is 2 plus 3? See? That's the pattern. It's always taking the two previous numbers, adding them together to come up with that next term. This is a recursive formula. Okay? So, what I'm going to do is I'm going to write that recursive formula. So, here's a couple things that you need to keep in consideration. One, to write a recursive formula, you have to tell them your previous term's value, or sometimes, if multiple terms are needed, you have to tell them the previous terms that are needed. So you always start off by at least defining your first term. Now, in the Fibonacci sequence, we needed the first two terms to find the third term, and that's why they immediately defined what a sub 1 was and a sub 2. Y'all see it? Now, I want you guys to think from a logical standpoint as we write this equation. If I was finding the third term, what did we need? We needed a sub 1, and we needed a sub 2. And what did we do with them? We added them. Y'all with me? Now, what if I wanted to find the 18th term? Following this pattern, what would I need? I would need a sub 16. I would need a sub 17. And what would I do with them? I'd add them together. All right, here's the point. We're not defining those individually. We're defining them as a sub n. Okay? We have to write an equation that puts that concept into an equation without specifying what term we're trying to find. It's to find all the terms. Right? So how would we do that? Yeah, there it is. So, like you see right here, you are given the two previous values. How far away from a sub 3 is a sub 1? It's 2 away. 2 below, isn't it? How far away is a sub 16 from a sub 18? Same. It's 2 below. So if you heard, that's exactly what you do. To define that first term, you do a sub n minus 2. We can do the same thing with the other one. That's 1 below. That's 1 below. So I'm going to define that as 1 below as well. So my equation for the Fibonacci sequence is a sub n equals a sub n minus 2 plus a sub n minus 1. We call on the previous two terms. and we add them together. That is recursive formula. So I'd love for you to write one thing down here. Recursive formulas have to have at least one previous term in it. Okay? And that is how I want you guys to refer to the previous term. That's the previous term value, a sub n minus 1. So if you ever see an equation and it has a sub n minus 1 in it, what is that doing? It's calling on the previous term's value. So if you ever see a sub n minus 1 in the equation, whether it's right now or whether it's on the ACT, you know it's what kind of equation? Guys, what kind of formula is it? It's recursive. Y'all hear me? If y'all ever see a sub n minus 1 in an equation, it's recursive. It's calling on the previous term's value. So, look at a couple of examples. And what we're trying to do is we're trying to find the first 5 terms of the sequence. Now, the beauty of recursion is this. They already have to tell me at least one, don't they? Remember, you can't write a recursive formula without telling people where to start, right? You got to know a previous term. And what do they tell me my first term is on number 1? They tell me your first term is 14. So we really only have to find how many? We only have to find 4 more. So look at the equation. To find a sub n, to find any term, here's what you do. You take a sub n minus 1 and you do what to it? What do you do to a sub n minus 1? You add 9. Now, what did I just say a sub n minus 1 is? You take your previous term's value and you add 9. So if I want to find a sub 2, that whole concept of a sub n minus 1 means this. If I plug 2 into n, what's 2 minus 1? 1. So if I want to find a sub 2, I plug 2 in, it gives me a sub 1. If I want to find a sub 2, I've got to take a sub 1 and add 9. What if I wanted to find a sub 15? Well, 15 minus 1 is what? So I have to find a sub 14 and do what to it? Add 9. See, you have to take the previous term and then make that change. Are y'all following me? That's what recursion is. You take the previous term and you make some change to it. In this problem, you're simply adding 9. So how do I find the second term again? I take the first term's value, which is, and I add 9. What's 14 plus 9? 23. How do I find the third term, guys? I take the previous term's value, 23, and I add 9, 32. How do I find the fourth term? I take the previous term's value, 32, and I add 9, 41. How do I find the fifth term, my last one? I take the previous term's value, 41, and I add 9, 50. That's my first 5 terms. See, recursive formulas build off the what? Previous term. Y'all understand that? So look at the next problem. Again, they want us to find the first 5 terms. Well, what did they tell me right off the bat? Your first term is, so I know first term 6. Now, how do I find the second term? Well, let's look. There's my a sub n minus 1. What's happening to it? It's being multiplied by 2 and then subtracting 5. Every time. It's taking my previous term, it's multiplying by 2 and subtracting 5. You take your previous term, you multiply it by 2, and you subtract 5. Here we go. What's my previous term if I'm trying to find my second term? What's 6 times 2? 12 minus 5. 8. So my second term is 7. How do I find my third term? You take your previous term, you multiply it by, what's that? And you subtract 5. My third term is 9. How do I find my fourth term? I take my previous term's value, 9, I multiply by 2, that's 18, and then I subtract 5, 13. Yes, ma'am.
It's not being silly. Well, no, just go ahead and finish and then I'll ask.
Okay, last term, fifth term, I take my fourth term's value, 13, I multiply by 2, 26, I subtract 5, 21. There's my first 5 terms in this particular recursive formula. Okay, now ask your question. It's probably not dumb.
What does the 4n greater than or equal to?
It's just saying they've given you your first term,
Oh.
so don't start until your second term. Don't start until a sub 2, you know? Alright, that's it. You don't even really have to define that. Okay, so which one do y'all want me to do, number 3 or number 4? I'm going to do one more of those.
Number 3.
Number 3?
Yeah.
Okay, so look, a sub 1, my first term's value is what? 354. We want to find the next 4 terms. So look at my equation. Y'all see a sub n minus 1? That's how you know this is recursive. Now, you tell me, what does a sub n minus 1 mean?
The previous term.
I want you to think about it like that, Caden. Everybody. It's the previous term. So look at it. What are we doing to the previous term? Adding 6 and then dividing by 3. That's what your mind is doing. It's taking your previous term, adding 6, dividing by 3. So let's do that. To find my second term, I take my previous term, 354, plus 6, 360, divided by 3. 120. There's my second term. How do I find my third term? Same thing. Take your previous term, add 6. That's 126. Divide by 3. 42. 42 is my third term. How do I find my fourth term? Add 6 to 42. That's 48. Divided by 3. 16. How do I find my fifth term? Add 6. That's 22. Divide by 3. You could use a decimal. It's 7.3 repeated. Since that's my fifth term, I don't have to find any more. We're good. You could have done 22 over 3. You could have done 7.3 repeating. You could have done 7 1/3. Okay. Any questions with that? All right. Last concept's a little harder. We're going to write an actual recursive formula. Okay. So first, remind me, what do you have to tell the people who are seeing this problem when you're writing a recursive formula? What do you got to tell them? Nope, before that. You got to tell them what you start with, right? You got to tell them a sub 1 equals what? 4. You got to tell them where to start. Then you define the equation. All right, so here we go. I want you to think real simply. When numbers go up, what are your possibilities? Adding. That's the first thing I think of, right? So how do I get from 4 to 11 by adding? Plus 7. So what's 11 plus 7? So that doesn't get me to 32, right? So I'm not just adding 7. What else can I do to make numbers get bigger? What's the first number I can multiply something by to make it change? 2. So let's multiply by 2. What's 4 times 2? 8. How do I get from 8 to 11 now? So let's try to add 3 as well. We're going to multiply by 2, add 3. So what's 11 times 2? What's 22 plus 3? Closer, but not quite there. What's the next thing I can multiply by? All right, so let's try that. What's 4 times 3? I overshot it. How do I come back to it?
Subtract 1.
Subtract 1. Let's try that. What's 11 times 3? 33 minus 1? Found it. Every time I'm taking the what? Previous term. What else do we call that?
A sub 1.
A sub n minus 1.
And that's 1.
And I'm doing what to that a sub n minus 1? I'm multiplying it by 3.
Subtracting by 1.
And I'm subtracting 1. And there's my equation. You got to tell people the first term. A sub 1 equals 4. And then I find every term after that, a sub n, by taking the previous term, a sub n minus 1, multiplying it by 3, subtracting 1. There's my equation. Does that make sense? It's a little challenging. Let's look at one more. How do numbers get smaller? What's your first thought? Subtraction, right? So 100 minus 40 would get me to 60, right? What's 60 minus 40? It's a little off. So I'm going to have to do something else too. What else can I do to make numbers smaller? What's the smallest number you can divide by and make a change? What's 100 divided by 2? How do I get from 50 to 60? Add 10. Let's try that pattern. What's 60 divided by 2? 30. What's 30 plus 10? Did I find it? There it is. I'm dividing by 2, and I'm adding 10. That's my pattern. So let's tell the people what they need to know. They need to know the first term. So a sub 1 equals 100. They got to know it. They can't start a recursive formula if they don't know what the first term is. You got to tell them. Then the equation is a sub n equals, and remember what we do? Every time we were taking the previous term, guys, define that formula. The a sub n minus 1, and we're doing what to it? So we're taking a sub n minus 1, we're dividing by 2, and then adding 10. That is my recursive formula. Somebody asked me in second period, could I have taken a sub n minus 1 and multiplied it by half and then subtracted or added 10? Yes, that works as well. Multiplying by half is the same thing as dividing by 2, so that would have worked too. But you still got to tell them the first term. So that's where we're going to stop today. We probably could have jammed in that last one. I know, not now. Not since y'all locked me out of my own classroom for a while. No, actually, here's the wild thing. That probably has never happened in here this year. This worksheet right here is technically 3 nights of assignments.
What?
Yeah. That's actually a good thing. Instead of dividing it into one night, this is 3 nights. What's wrong with that? Huh? So tonight, you're going to do 1 through 6. And then we're going to do explicit formulas tomorrow. And you'll finish that. And then we're going to do series. And then you'll finish the rest of that worksheet. So it's actually going to be 3 nights homework assignments.
What are we showing it like? Are we showing like every day?
Well, no. I'm going to look at it Wednesday after we finish sequences. And then I'm going to look at it Thursday after we finish series. So I'm actually going to, I'll put the homework answers up tomorrow, and we'll talk through them if you have questions. But I won't check the grade and give you a homework until tomorrow. So it's 3 nights assignments, but it's going to be 2 homework assignments. Yes. Yeah. So 1 through 6, and I think some of you guys probably will really struggle with number 6. I hope that you try it yourself, and maybe you will struggle, and maybe you'll figure it out. But number 6 is pretty tough. I will give you this hint about number 6. Are y'all listening? Number 6 needs 2 previous terms. It's kind of like the Fibonacci sequence. It needs 2 previous terms. So take that for what I tell you and see if you can figure it out.